how to assign the formal charge. We mean by the formal charge the charge on the ions, similar to when we write the nitrate ion, we write minus on the top of the nitrate ion, or like we write the plus on the top of the ammonium ion. So how did we know? We need to write minus on the top of nitrate ion and plus on the top of the ammonium ion. The first step to assign the formal charge is to calculate the total number of valence electrons of each atom. For example, carbonate ion. Let's calculate the total valence electrons. The number of carbon valence electrons is equal to 4. And the number of oxygen valence electrons is equal to 6. The total valence electrons of carbonate is equal to 4 plus 3 oxygen atoms. Each has 6 valence electrons. So the total is equal to 22 valence electrons. In the second step, we write the chemical sample of each atom, then distribute the electrons around the central atom to satisfy the octet rule. If you count the electrons around the carbon, you will see that carbon is singly bonded to 2 oxygens and doubly bonded to 1 oxygen to have the 8 surrounding electrons. The third step is to add the extra electrons, so the remaining electrons are in pairs. So we need to add 1 electron to this atom and another electron to this oxygen. We added 2 electrons, that is why we have -2 on the top of the ion, because we added extra 2 negative charges. This is how formal charge is determined. For simplicity, we use a formula to calculate the formal charge. The formal charge is equal to the valence electrons of the whole molecule or ion minus the sum of unbonded electrons and half the bonded electrons. Let's apply this formula to carbonate ion. First, we need to calculate the valence electrons of the carbonate ion. Carbon has 4 valence electrons. There are 2 oxygen atoms singly bonded with valence electrons equal to 6. So 6 multiplied by 2 equal to 12. Then the valence electrons of the doubly bonded oxygen atom, which is equal to 6 as well. The total number of valence electrons is equal to 4 plus 12 plus 6 equal to 22. For carbon, there are 0 unshared electrons. The 2 singly bonded oxygens have 6 unshared electrons multiplied by 2 because there are 2 oxygens equal to 12. The doubly bonded oxygen has 4 unbonded electrons. The total number of the unshared electrons is equal to 0 plus 12 plus 4 equal to 16 electrons. Now moving to the number of bonds. Remember, after we count the number of bonds, we will multiply it by 2 because each bond is formed of 2 electrons. So carbon has 4 bonds and the singly bonded oxygens each has 1 bond. So we have 2 and the doubly bonded oxygen has 2 bonds. The total number of bonds is equal to 4 plus 2 plus 2 equal to 8 bonds multiplied by 2 equal to 16 electrons. Notice it would be easier to just use the number of bonds instead of counting the number of bonds and multiply it by 2, then multiply it by half to get the half number of the shared electrons. But just let's follow the formula exactly. So the formal charge is equal to 22 valence electrons minus 16 unshared electrons and half multiplied by 16 shared electrons equal to -2, which is the number written on the top of the carbonate ion. Let's solve this exercise the same way. Assign the formal charge of ammonium ion. So we have 1 nitrogen atom bonded to 4 hydrogen atoms. If we count the electrons surrounding the nitrogen, it is 8 electrons. 4 bonds. Each bond consists of 2 electrons. Let's calculate the valence electrons for ammonium ion. 5 valence electrons for nitrogen. Hydrogen has 1 valence electron multiplied by 4 because we have 4 atoms equal to 4. So the total number of valence electrons is equal to 9. There are 0 unshared electrons, no lone pairs. For the number of bonds, nitrogen has 4 bonds and each hydrogen is singly bonded. So 4 plus 4 equal to 8 bonds multiplied by 2 equal to 16 electrons. The formal charge is equal to 9 valence electrons minus pause, the 0 unshared electrons and half multiplied by 16 for the bonded electrons equal to 1. This is the plus we usually write over the structure. Actually, a quick way, if we count the number of electrons surrounding the central atom, nitrogen, it is equal to only 4 valence electrons, not 5. So we are less than the number of the valence electrons by 1. This is the plus we usually write over the ammonium ion. Let's look at this exercise. Draw the Lewis structure for these ions and show which atom in each bears the former charge. Hydronium and bicarbonate ions. You can stop the video and try to solve the exercise. First, hydronium ion. We write the sample, then we draw first only one single bond between each atom. Secondly, we count the electrons around the central oxygen to satisfy the octet rule. Remember, each bond contains 2 electrons, so 1, 2, 3, 4, 5, 6 bonded atoms, so we need another 2 electrons to satisfy the octet rule. 2 electrons on the top as a lone pair. Now let's fill in the table. Oxygen has 6 valence electrons, each hydrogen has 1 valence electron, and there are 3 atoms, so 1 multiplied by 3 equal to 3 electrons. The total number of valence electrons is equal to 6 plus 3 equal to 9. There are 2 unshared oxygen electrons that we draw on the top of the oxygen atom, and the hydrogen has 0 unshared electrons, so the total number of the unshared electrons is equal to 0 plus 2 equal to 2. Moving to the number of bonds, oxygen has 3 bonds. Each hydrogen is bonded with one single bond, so 3 hydrogen bonds. The total number of bonds is equal to 3 plus 3 equal to 6. 6 bonds contain 6 multiplied by 2 equal to 12 electrons. The formal charge is equal to 9 valence electrons minus 2 unshared electrons and half multiplied by the 12 bonded electrons equal to 1. Now moving to the bicarbonate ion. You have the central carbon atom bonded to 3 oxygen atoms, and one of the oxygens is bonded to a hydrogen atom. Now if you count the electrons surrounding the carbon, you will find that there are only 6 electrons, so the carbon must be doubly bonded to one of the oxygens. The oxygen atom next to it, oxygen number 1, this oxygen is bonded to 1 hydrogen atom and 1 carbon atom. Only 2 electrons, and we have the valence electrons is equal to 6, so we need to draw 2 lone pairs of electrons. 1 lone pair at the top and 1 lone pair at the bottom. The oxygen on the top, oxygen number 2, is doubly bonded to the carbon. 1, 2 electrons. We need to draw another 4 electrons. Finally, oxygen number 3, which is singly bonded to carbon, so only 1 electron. We need to draw the rest of the 6 electrons. 1, 2, 3, 4, 5, 6. This single electron, we will add another electron to it, so they are in pairs. Let's fill in the table. Carbon has 4 valence electrons, 0 unshared electrons, and 4 surrounding bonds. The hydrogen atom has 1 valence electron, 0 unshared electrons, and 1 bond. Oxygen number 1 has 6 valence electrons, 4 unshared electrons, and 2 bonds. Oxygen number 2 has 6 valence electrons, 4 unshared electrons, and 2 bonds. Oxygen number 3 has 6 valence electrons, 6 unshared electrons, and 1 bond. The total number of valence electrons is equal to 4 plus 1 plus 6 plus 6 plus 6 equal to 23. The total number of unshared electrons is equal to 0 plus 0 plus 4 plus another 4 plus 6 equal to 14. The total number of bonds is equal to 4 plus 1 plus 2 plus another 2 plus 1 equal to 10. We multiply the 10 bonds by 2 equal to 20. Now let's apply the formula. 23 valence electrons minus 14 non-bonding electrons, and half of the 20 bonded electrons equal to minus 1. This is why we need minus on the top of the ion.